All right. So welcome. This is Glaciers Lab 3, Lab 11 overall. After this, you only have one more, so you're all doing well. Almost there. So this lab is concerned about snow stratigraphy. And stratigraphy is the study of layers that build up over time. So this is really common with rocks and snow. Like if you've ever seen the Grand Canyon, it builds up in those nice layers, and we can study that. Same thing happens with snow. You get one layer and then more snowstorms pile on over top, and we get these layers that we can look at. That's stratigraphy. And then some other vocab that I'll mention for this lab. The amount of water contained in a snowpack is called the snow water equivalent. So this is important when we're looking at like densities, for instance, because we know the density of water and we'd expect snow to have a density less than that. A difference in temperature throughout something is called a temperature gradient, so a change in temperature. We're going to be looking at that a lot in this lab. So like maybe we could put thermometers throughout a pile of snow and see, is it the same throughout or is it changing? That would be a temperature gradient. And then the word metamorphism refers to the change of shape of something that underwent some type of change. So these are some pictures from the lab. On the left here, this is a snow pile on the ground, and on the right, this is a snow pile on a picnic table. And there's a few things going on here. So they were measured. The ground pile is around 34.5 centimeters and the picnic table around 30 centimeters. Thermometers were stuck in the snow at different levels to see is it the same temperature or is it changing. And then these squares are samples that were taken out. And let me just play. Let's see. Okay, so let me just play this video so you can get a look at it. It's on Canvas for you.
Okay, so I'm at the table snow pick, and as you can see, the total depth is about 30 centimeters. I've got thermometers placed at 5, 15, and 25 centimeters. And I'm going to take the first snow density sample with the base at 5 centimeters. So I've kind of marked it, and I'm going to put the box in. Then a little tricky to kind of scoop it out very carefully. And then I use this tool to cut it exactly, get off any extras. Now I have a perfect little box of snow that I dump into my sample bag. Okay.
So simple enough. It's on Canvas if you want to watch it again. So that's how those samples were taken. So question 1 is asking for the average mass of one empty sample bag. So we're going to need this when we're calculating the density of the snow because we're measuring the bag and the snow, but we don't want the bag. So we would need to know the mass of the bag so we can subtract it. And in the lab, it gives some other notes of just measurements that were taken. And one of them tells us the mass of 5 empty sample bags, which is 23.5 grams. So simple enough, we can just take 23.5 and divide that by 5, and that will give us the mass of one bag. So that's how you do question 1. Questions 2 through 7 are looking for the mass of the sample only. By sample, that snow square that they took. We have multiple samples for the table and the picnic table, ground and table. So all we'd have to do is take the mass of the sample and the bag, which are given to us, and subtract that by the mass of the bag, which we calculated in question 1. And that will give us the mass of the snow only right here. And then from there, we can calculate density. If we remember from past labs, density is going to be mass divided by volume. It's kind of hidden in the lab, but it tells us that the volume is 200 centimeters cubed. So we can just take whatever answers you got from questions 2 through 7, the mass of the sample only, the one that you subtracted the mass of the bag of. You can take that, divide that by 200 centimeters cubed, and that will give us the density of each of the snow squares. Question 15 through 20 is asking for you to find the temperature gradient, that change in temperature throughout the snow pile. And then first we would need to know the temperature difference. And so we can find that by taking the uppermost measurement and subtracting that by the lowermost measurement, looking at the degrees Celsius. So an example, you would want to take negative 8.1 minus negative 3.8 degrees Celsius. And just be really careful with science here because it gets kind of confusing when you're plugging in a calculator. Make sure you don't drop any signs. It's going to change your answers entirely. But we do this and you can get the temperature difference. And then we would also need the difference in distance. And it gives us the locations at which the measurements were taken at 25 centimeters and 5 centimeters, and they're the same for both the ground and table. But the big thing you have to do here is you need to convert it to meters. The next part, calculating the actual gradient, it needs to be in meters or your answer is going to be wrong. So I would just take 25 minus 5, find whatever that is in centimeters, and then convert that to meters by dividing it out by 100. That'll give us that difference in distance in meters. And then we have this nice equation here to find the temperature gradient. And we already did the top part. You would just take the uppermost minus the lowermost temperature. It's whatever you found for this temperature difference. You could plug it in again if you want. And then you would divide that out by the distance you just found in meters. And that will give us the temperature gradient. And then there's some questions asking you to kind of interpret what you did. So something to help you, if your sign is negative, it means that the top of the snow is colder than that of the bottom. And if the sign was positive, it means that the top was warmer than that of the bottom. And if it's 0, it would have been constant or close to constant. So you can kind of use that to help you in your answers. Okay, the next part of the lab is looking at a glacier here. We're looking at this glacier here. We have 3 different sites, A, B, and D. Wherever it is, the snow is really white, that means that there is accumulation, meaning that snow is building up. Then that's like site D here, really white snow, right? If it's more brown, that's called ablation, where snow has already melted and it's just leaving the rocks and dirt behind. That's closest to A. I know there is still some snow, but it's mostly dirt over here. So that's ablation. And then if it's a mix between white and brown, it means that maybe there's some melting, but not really entirely. It's probably more just staying constant. And that would be like site B. So D is growing, A is melting, B is staying constant. So with this, we can try to get at the mass balance for questions 29 through 31. And we have an equation here for this, and it's already kind of set it up for all the units to cancel for you, so you don't have to worry about that. And we can find the winter balance by plugging in this first value here. The snow depth into this first value here. So this is a sample for site A. You would just take 0.8, plug it in, be careful with your like decimals and signs and all that. And that will give us the winter balance. For B, that would just be 1 plugged in here. And for D, that'd be 1.5 plugged in here. That would be the winter balance. And everything else stays constant. The snow density is the same for everything. The water density is the same for everything. So that's why that's not changing. Okay, so then we can find the annual balance because we have both the winter and summer balance. The annual balance is that difference between how much was accumulated in the winter versus how much melted in the summer. So we could just take that winter balance and subtract by the summer balance. Be really careful with signs here because you might have negatives and that's okay. If you get a positive answer here, that means that the glacier was growing. And if you've got a negative answer here, that means it was melting or retreating. So just be careful with your signs. But one issue you might notice is there is no summer balance for B. We have to find it. And so question 33 does ask you, well, what is the annual balance at site B? You don't really need to do math for this. This is a little bit more like of a logic check. You just need to look at this image. So remember what I said before, site B is kind of that mix between snow and dirt. D, it's really white. We'd expect it to accumulate. A looks like it's melting. We see more of that dirt. And B looks in the middle. So if it's positive, it's growing. If it's negative, it's melting. And the value would be 0 if it's staying constant. So do with that as you will. And then from there, we can so yeah, question 35. Now that we know the annual balance of B, what is the summer balance? So you would just use the same equation as before and just solve it a little out of order. You would have found the winter balance already. You'd have the annual balance, and then you have everything you need to find whatever that summer balance was for B. And the last part, questions 38 and 39 are asking about glacier volume. Volume is going to be the annual balance average times the area. We can find the annual balance average by taking your answers to 32, 33, and 34, these three. You can add them up, and then you would divide by 3 because we have 3 samples. That would give us the average. And then to find the area, the lab tells us that the area of the glacier is 19.8 kilometers squared, but we would need to convert that to meters. For question 38, you just multiply by 1,000,000. That would convert us to meters. And then we'd have everything we would need to find the volume. You would just take that average that you found this way and multiply that by your area you converted to meters, and that would give us the volume of the glacier. Once again, be careful of your signs, they're important. And that's it. So please, please, please ask questions if you have them, and yeah, have a good week.